So this is part of an ongoing Web Age Technology webinar series. Today we're going to talk about the business decision process of choosing the cloud. The focus less on the technology itself and more on making a business decision. And as you might have seen in the introduction to this class, there's only two reasons to make a business decision. You make a decision in business in order to make more money or increase revenues, or to save money. Any other decision that you make in business is a hobby decision. Fundamentally, as business people, as managers, this is the guidelines that we have to take. So we're going to cover this in terms of what the top 3 providers can give us in the cloud. We're going to talk about this in terms of the origin of the cloud. We'll talk about why just 3 providers. Why am I not including other folks in here? Then we'll dive into the risks and rewards of the cloud, and we're going to cover these in terms of a management perspective. Risks that are typically associated with the cloud, but are not unfamiliar to you in making any decision about technology. Then finally, we'll talk about making this decision itself. We'll talk about the decision criteria. We'll talk in general where a particular cloud fits, but we won't make any specific recommendations because it depends. I am an engineer, and you can always tell the difference between a salesperson and an engineer, because if you ask them, hey, does this product do this for me? A salesperson will say yes, and an engineer will say it depends. So in making the decision, I'm going to give you some criteria, some of the ways to approach this, but it will depend on your own unique circumstances. Okay, so let's talk a little bit about what the impetus was for creating the public cloud. The impetus for the public cloud is something that everybody who is engaged in information technology, everybody who has a technology backbone to their enterprise is familiar with. That IT projects have an enormous failure rate. And by failure rate, what I'm talking about here is the reasons that we created the project in the first place aren't met. The requirements, the conditions, the goals, they're not met. And we end up having to accept half a loaf at best. It's relatively rare, on the order of maybe 20% of the time, that we get what we actually wanted from a particular IT project. And why is that? Well, we didn't account for risks. There's a lot of things that fold into that. Another thing that the public cloud had to address was exponential growth. We have had companies, and we'll discuss 2 out of the 3, or actually all 3 of the companies we discuss here have experienced exponential growth at some point in their history, and we experience this all the time for successful companies. You know, think about how quickly companies have had to scale in order to make an impression on us. Whenever I lecture about business, I tell people that the 2 things that kill business are failure and success. Failure, running out of money, not making your market, not making your product, obvious. But success has killed almost as many companies as failure has. Success, that exponential growth of keeping up with, hey, we have so many opportunities, we're going to chase after all of them. We need to increase our staff. We have these HR problems. We don't even have telecommunications or networking that can keep up with it. So we are all familiar with companies that have done that as well. So exponential growth, we have to manage that. And then finally, the last 2 ones are a little bit more subtle. Democratizing technology. As technology has made inroads in all of our lives, I'm sure that some folks here are watching this webinar on a smartphone. Think about the fact that you have something in the palm of your hand that lets you listen to some guy lecturing in Portland, Oregon, displaying graphs and sharing this experience with over 70 other people. The democratization of technology has been profound. and the expectations of people who walk into a company with their iPhone or Android, with their laptop, that they will have access to technology, and this technology can be leveraged to make them more effective in your company. That is a huge expectation. And along with it comes the idea of managing risk. You know, just inserting technology into a company is not guaranteed to create a good situation. It's not guaranteed to be successful. There are an enormous number of risks, an enormous number of dimensions that risk can occur. So the public cloud was actually created to address these. And it was created, so backing up a second here, let's talk about about point number one, IT projects failure rate. This comes from a company that monitors systems. So you can see it's a kiosk project. And the latest one I could get a hold of was up to 2015, but you can see that it's pretty steady state. And these are self-reported projects. These are polls that go out to IT CIOs and such, asking them what percentage of their projects succeeded, were challenged, or failed. Succeeded, meaning that they are entirely happy with the results. In other words, it met the criteria that they started the project. Challenged, meaning it's crippled in some way or didn't meet those goals, or outright failed. It's pretty steady state that self-reported projects in this particular survey hover at 30% or less. When asked why, or asked based on the size of project, note that in general, the smaller the project is, the more likely it is to be successful. And let's make a note of this, that if we are moving ahead in small steps rather than giant moonshot leaps, we will have more success than failures. So you have a 62% success rate here. And that was one of the lessons that the people who created the public cloud really took to heart. The idea of incremental steps of small projects, boiling down to something that Amazon calls the two pizza idea, that IT project teams should never be larger than the number of people that can be fed by two large pizzas. And it's both a joke and a truism that when you think about, well, if it's me, I'm kind of a large guy, so maybe there's two people on the project. But if you think about the number of people two large pizzas can fit, and the ease can feed, and the ease of communication between them, the peering relationships that occur between them, you can see that using that as a criteria would be very, very effective to making sure that your teams are more interoperative, more peered, and more communicating. You start, when teams get bigger than that, let's say 10 pizzas, you start to have coordination. You start to have formal pipelines between them that may or may not capture all the needs of communication. So small projects tend to win. As does the focus of senior management. In looking at successful projects, again, these are from CIOs, CTOs, etc., and directors. They self-reported that the top three, being executive sponsorship, emotional maturity, and user involvement, these are all soft skills. These are all the skills that management is responsible for, that management brings to a team. The coordination, the sponsorship, the focus. You only get down to actual skills and technical capability on the fifth one. And things like technology and processes for technology at Agile is down the seventh one. So self-reported, you have senior management saying, it's successful if we are involved, if we are invested. Okay, so as we probably all know, the classic case for an exponentially growing company would be Amazon. This is a timeline of some of the accomplishments of Amazon. Amazon started off in 1994. The first website for Amazon was actually put out in 1996. Between 94 and 96, Amazon built, without a website, a $20,000 a month run rate. And once they created a website, and once they created the capability of buying more things than books, they just took off. And in the year 2000, 2001, Jeff Bezos looked out across all this and realized that he was facing an enormous amount of risk. IT project failures are endemic. You know, no one is bulletproof. So what he looked at across is, how am I going to maintain this explosive growth rate, this incredible diversification that's occurring in the company, and not be crippled by failures or challenges or problems within my IT infrastructure? And what he decided to do was create a brand new way of approaching IT. So there is a famous, among technologists, memo written by a guy named Steve Yeager, and you can Google the Steve Yeager memo. This came out in 2011. Steve Yeager was a Googler, and Steve in 2011 put out this memo that basically said, Amazon is a company that does almost everything wrong. Google is a company that does almost everything right. Here's why Amazon's going to eat our lunch. And he reviews his own participation in creating the Amazon Web Services, or AWS. As part of this, so this memo, he wrote it up and he sent it out to all of Google, but he forgot to mark it private. So it went out not just to Google, but to everyone who was connected to Google+. So there was a brief hoorah. If you do Google Steve Yeager memo, you see there's a "will Steve be fired?" yada yada. But Google actually accepted this criticism and used it to make a much more effective product. So, but Steve Yeager is talking about with this memo what Amazon did to mitigate risk and to refocus the company on creating small building blocks for IT projects. So you can see point number one, that anyone providing services, compute services into Amazon would do so through a service interface. And these teams, let's say you're the print team, and then you're talking to the storage team, who's talking to the networking team, who's talking to the security team. Everyone will communicate through these service interfaces. There will be no direct linking. There won't be any backdoor. There won't be any. So I am the print team. If I'm maintaining a print queue, no one can see the database that maintains the queue directly. They have to go through my service interface, an API call. So the key here is that the only communication, the only way to invoke printing, the only way to invoke storage, the only way to create networks is through interface calls over a network. It did not matter what technology the service interface used. That changed. So when the memo was first put out, it didn't specify a service interface. This has now evolved to REST, which is APIs maintained over HTTP. Note number 5 here. This memo was originally meant to govern IT projects within Amazon. But number 5 says that the teams, that the service interface must be secure enough to be used by the outside world. In other words, Jeff Bezos not only saw that this IT problem and this risk that you had with IT projects occurred within Amazon, it occurred across everyone's domain, that everyone was facing the same sorts of project failure rates. And number 6, anyone who doesn't do this will be fired. Again, I highly recommend you find the Steve Yeager memo and read it, because it's a very funny insight into the definition of comedy is tragedy plus time. Funny in this context means that since it's so long ago, it seems funny, but at the time, imagine changing an entire company's approach to IT, and within 2 years they'd done it. So the result is that Amazon now had a 100% API-driven IT infrastructure. If you were a developer inside of Amazon and you wanted and you're writing a function for Amazon.com, let's say you're writing the search function. You provide an API to your user interface people. So you focus on search, and the user interface people call your search via the API. So you don't worry about how the user interface looks. You are focused on making sure that search works as effectively as possible. Someone comes back to you and says, I want to, our search not only needs to be able to understand ASCII characters, but UTF-8 characters so that we can have non-Roman or even ideographs. Okay, so now I can change my search to do all this and not have to worry about the implications for anyone else, because my border, my responsibility lies in supporting my API call. If my API call now supports UTF-8, no problem. I don't have to worry about how UTF-8 gets portrayed on the screen. So that was all great. We provide services this way, but it also evolved into being able to create the entire infrastructure itself. So we end up evolving towards infrastructure as code. So if you're providing networking services via an API call, well, now there's an API call to create a network. We have this software-driven network infrastructure behind it. On the flip side of that, you start to pay for only what you use. If you're making an API call in order to create a storage facility, you read and write to the storage facility. When you're done with the storage facility, you delete it. Same thing with compute. I need to spin up a server. So I will spin up a server. I will use the server. When I'm done, I delete it. So that I start to be, since this infrastructure is programmable, I can write a program that uses as much of the infrastructure as I need and then deletes it when I'm done. Along with that, that also means I can scale. That the people who are maintaining the compute infrastructure are doing so such that I can add more compute to my application as I need it. And then finally, because I have these API calls, I can create very fine-grained control. Rather than having to open up to anyone who has access to my user interface, I can, on a per API call basis, impose control on things like, oh, this person is making this API call. Let me examine what the originating IP address is. If that originating IP address is not within the corporate VPN, I'm not going to accept that API call. If this person is making an API call to delete a storage facility, but it's outside of business hours, I'm not going to accept that API call. So we can create this really fine-grained control, and because these are API calls, I can monitor every time the API call is made and log that. So I instantly have finer-grained control and auditability. So this evolves towards cloud computing, and we can see how this evolves based on the definitions that people give us. For AWS, it's the on-demand delivery of compute, storage, applications with pay-as-you-go pricing. Microsoft, same sort of thing. Delivery of compute services. Everything you can imagine for compute services over a network, over the internet. Google, building and maintaining data centers is replaced by consuming IT resources. So what Google's being more upfront about it, saying, look, we are the experts at massive data centers and massive data collection and massive compute. In the same way that your local electric company is able to generate and maintain and distribute megawatts of energy. I grew up in San Diego, California, and it's a relatively new city. One of the grand houses in San Diego is a house called the Marston House. George Marston built it. He started a chain of department stores in the local area, became quite wealthy, And he built his house on the edge of Balboa Park. If you've ever been to San Diego, it's this grand park, beautiful area. The house itself overlooks this beautiful canyon. It's an incredible place. But he built it in 1906, and it was considered to be the edge of San Diego at the time. So when he built the house, he put a generator in the basement in order to have electric light. 2 years later, he rips the generator out because the local electric company had started and was able to give reliable power to his house. So he no longer had to maintain that. I fully believe we're at this point right now where you're choosing between buying your compute services like electricity or maintaining your own generators. There are reasons for doing both. There is no one set way of doing things. Everything comes down to your evaluation and understanding the risks, understanding the rewards, and making the decision. Okay. With that, what are the benefits of moving to the cloud? Well, as we said, on-demand resources. I need a compute right now. Maybe I only need this compute to run during office hours from 8 a.m. to 5, 6 o'clock at night. At 7 o'clock, I should turn it off or spin most of it down. So that factors into cost control. Making sure that I'm only using as much resources to meet the need I have right now, which factors into scalability. If the infrastructure doesn't scale, doesn't respond to my needs, then I'm not going to have cost control because I'm going to have to maintain enough headroom in my system to allow for my peaks. We also need flexibility and elasticity. We need the ability for our system to do things like test. One of the advantages of the cloud is that an engineer can approach their management and say, look, I really think that if we ran on a different platform, more CPUs, different memory, higher throughput, would be a lot more cost effective. Using the cloud, you can do those sorts of tests. You can budget $100. Say, okay, here's a budget of $100. Do a apples to apples comparison of throughput using different platforms and come back to me with that report. So this flexibility, elasticity allows you to do these things, to experiment. Also allows you to do something that IT has never really had the opportunity to do, which is go back and engage in continuous improvement. Okay, we got it all up and running. Okay, everything's great. At this point, if it was our data center, we would carefully back away. Say, everything's running, don't mess with it. In the cloud, we have to do that in the data center because we spent capital dollars. You know, being more efficient in our compute doesn't mean we get any of those capital dollars back. In the cloud, though, if we become more efficient, then we start to save money. And every dollar you save, it goes directly to the bottom line. Then finally, availability. Also meaning things like how resilient we are. Stuff happens. If stuff happens at a scale that would interrupt the physical infrastructure, how do we react to that? Well, traditionally, we would have to build things like disaster recovery sites. Again, living in San Diego at the time, there was a lot of people in the Midwest who built disaster recovery sites in San Diego and then had to visit them in January and February to make sure everything was okay. With the cloud, we have the ability not only to have disaster recovery in other parts of the country, but maybe around the world. And then finally, security. Security has a bunch of factors that feed into it, but one of them is focus. And the more eyes you have watching something, the more secure it is. Just physically, there is no way an individual enterprise could afford or amortize the cost of thousands of eyeballs watching their network. But someone like a Microsoft, someone like a Google, someone like an Amazon can, because they amortize it across all their customers and it is their core business. In the same way that a bank has to invest in incredibly hardened vaults, incredibly secure facilities for handling money, an AWS, a Google, a Microsoft has to invest in the security infrastructure because they are a target. Their adversaries are state-level actors, in some cases the states themselves. Imagine an adversarial state picking on your infrastructure. Well, that happens every day for Amazon, for Google, for Microsoft. So let's do a quick history of the various cloud providers. The oldest in terms of the public cloud is Amazon. The very first product that Amazon released, first cloud product that Amazon released, was called the Simple Queue service. It was released in 2004. Officially, Amazon Web Services itself, named as AWS, started in 2006 with the release of the Simple Storage service. And it all came out of that memo that you saw, or the thought and the planning that went into that memo and the reaction to that memo within Amazon. So in other words, AWS is the external expression of Amazon's own internal IT development. So this is a great case of eating their own dog food, because this IT development is what allowed Amazon to go through this explosive growth. The company itself, and remember, when you are engaging with a company, what you're engaging with is their key capability, is their mission statement, is their reason for being. Amazon's key technology, key capabilities is supply chain. So, gun to the head, if you approached any Amazon senior executives and forced them to tell you, what is Amazon's secret? They would say supply chain. It started off with books, then became everything, and then became compute, video. Think of all the ways that Amazon is integrated into your life in a supply chain. And it was within days, then it was 2-day free delivery, then it's overnight. Now it's immediate, it's 1 hour in metropolitan areas. So they have this incredible supply chain that expresses itself in various ways. And in terms of AWS, it's expressing itself by providing these compute services. The potential weakness of working with Amazon is that Amazon looks across the universe of business for its opportunities. And this quote, which has been credited to Jeff Bezos, your profit margin is my opportunity. So you have companies that have been in business with Amazon and suddenly find that Amazon's in their same business. Most notable, Netflix. Netflix is still, though, on AWS, even though Amazon Prime Video is a direct competitor, because Netflix leverages that much capability out of AWS. I have spent time, though, with consulting with retail competitors of AWS, and needless to say, AWS is not their first choice for cloud. Okay, so the second major public cloud, Microsoft Azure. It was announced in October 2008. The official public release, fully available release, is February 2011. It is a purpose-built cloud, and by that I mean it was built from the ground up to be a public cloud infrastructure. So components of it do support things like Office 365, etc., but it has not been an integral part of Microsoft. They are learning about how to provide the cloud, and we'll talk more about that when we talk about their network. The key company capability is that Microsoft is a developer platform. Bill Gates famously complained about Apple when Apple was getting much better publicity than Microsoft and much friendlier, etc., and Microsoft was the evil empire. And Bill Gates pointed out, hey, look, Microsoft doesn't even capture 50% of the value it provides. And by that he meant that the amount of software that's written out there that runs on Microsoft Windows, that the developers paid for the operating system, sure. They paid for the compiler, sure. But Microsoft doesn't get a cut of every every time Tableau runs on Windows, of every time SAP runs on Windows. And think of that in terms of the mobile phone culture. If you buy an app for an iPhone, 30% of that price that you paid for it goes directly to Apple. If you've written a program in Windows, the amount of money that you charge the customer goes to you. I mean, your cost of goods sold does include things like having to buy a Windows license to run it on, but beyond that, the value is all yours to keep. So that's one of the things that Microsoft has, is a 30-year plus culture of providing the platform that developers and software providers can leverage to push products out. The potential weakness, though, of working with Microsoft is that the cloud is a profound change in culture for Microsoft. If there were a Nobel Prize for business, I would have to say the first one would go to Satya Nadella, who's the current CEO. He came from the cloud side, and he has turned this aircraft carrier around. This was a company that built itself based on license fees for operating systems and license fees for applications. So every 3 years a new operating system comes out, there's a big push in license fees. Every 2 or 3 years Office changes, big push in license fees. And you would innovate within those. With the cloud, Microsoft's kind of backing off and saying, we're going to provide these services, but our revenue stream is going to be based on how much people use this, versus I announce a new product and I get this big bump in license fees. I'm going to have to serve or create the service platform for 24/7 operations, so I will attract people to run in my cloud. And that's a profound change in culture. They're learning it. They're doing it very, very quickly. They've got $130 billion of cash to do it with, and they're obviously very competitive. So that's why they're number 2 out of the top 3 public clouds. And then finally, Google. Google announced a preview to what's called the App Engine, which was their first cloud product. The App Engine went general availability in November 2011, so officially, kind of based on official stuff, Google was the latest to come to the public cloud. App Engine, though, was not greeted with open arms by the marketplace, because App Engine is how Google does its own application development and provision. It is an environment that you write code and then you submit the code into an infrastructure, and the infrastructure automatically creates all the necessary components. So the developer is somewhat in charge, and the operations is more monitoring. It is a profound change from the 3-tier server, database, etc., that companies are used to. And that's a weakness in Google. Google is operating 8 to 10 years in the future. It's funny because App Engine now is a perfect platform for what's called microservice architecture. So decomposing our monolithic applications into cooperating services, App Engine is stellar for that. App Engine slides right in because 8 to 10 years ago, that's how Google was doing everything. So that's one of the problems, is that Google has advanced so far that it needs to make sure that it establishes the pathway for folks to find it. So Google has increased their portfolio for things like servers, like storage systems, like networks, and analytics programs that leverage Google's key mission. Google's mission statement is essentially to capture the world's knowledge and make it usable and accessible to everyone. That is an incredible statement, that they're saying, we will capture all the knowledge in the world and we'll make it usable and accessible to everyone. And you know they're a long way towards that. Probably everyone on this webinar uses google.com, probably have done things like talk to Google Assistant, hey Google, what's the forecast for tomorrow? Or hey Google, what's the batting average for the last 30 years for the Cincinnati Reds? Those sorts of questions that Google can answer for us. So the Google Cloud Platform itself leverages all those technologies. So the technologies that Google uses for search, for mapping, for Gmail, for all the products, Google has 8 products that have more than 1 billion users average a month. So at any point in time, there are 100 million people hitting return on Gmail. And the infrastructure that does that is expressed or available to you as a Google Cloud product. So the key company capability is to exploit big data, and interestingly, also machine learning. Just about every search that happens through google.com these days happens not as a result of algorithms, but as a result of machine learning. Machine learning that is either tuned to you individually, if you identify yourself. So I log into Chrome, Chrome knows me, Chrome knows my habits. So when I do a Google search, Chrome or Google is optimized based on my profile. But machine learning also returns search results if you're anonymous, just based on trends and such. So when Google first started, it had this algorithm called PageRank, which determined, hey, look, if this is a page on dung beetles and 20 entomologists point to it, I will consider this an authoritative page on dung beetles. Essentially, that's how it worked. PageRank hasn't been used for over a decade. What Google did instead was implement machine learning so that search results can be personalized and much more flexible. So those are our 3 cloud providers. Why only 3? Well, let's take a look here. This is the current picture of regions for AWS. You can see that there are 6 regions in North America, 1 in Canada, 5 in the US itself, and there's 1 more about to come online. So there are there's 1 region called GovCloud, and there's going to be a second GovCloud on the East Coast. GovCloud is unique in that it is a purpose-built network for governmental entities within the United States, federal, state, municipal, NGO, municipal authorities, those sort of, if you're a water authority, et cetera. Any governmental entity that has special security or compute needs can be in GovCloud. Everything else you see on the screen is publicly available. So you can see we have a region in South America, Australia, Mumbai. We have regions about to come online in Hong Kong, Bahrain, and Sweden. So we have this incredible expanse of regions throughout the world. I love this because this is the very first purchase order signed by Google. This is for their co-location. So this is the Internet Data Center Services Order Form for essentially 3 racks of equipment, and you can see they paid $18,000 a month for 15 megabits of access to the internet, and which bursted all the way up to 100 megabit. So and on the lower right-hand corner, you can see the initials are LP. That stands for Larry Page. Larry Page and Sergey Brin created Google. So Larry initialed that and said, okay, on September 25th, 1998, we'll start this process of connecting to the internet. Note that this is not even 20 years ago. We're coming up on the 20th anniversary of that next month. This is the current network. So the current network is spanning the entire world. And the links you see in green, the transoceanic links you see in green, are wholly owned or investments by Google itself. The link on the top, the faster link, established in 2016, that has 160 terabits worth of capacity. So in 20 years, Google went from having 15 megabit worth of capacity to 10 million times more capacity on a single link. So Google itself has regions in many ways that look the same. Sao Paulo for South America, Mumbai, Taiwan, 4 or 5, sorry, locations within Europe, one coming online in Switzerland, 5 locations within the US, and 1 location in Canada. This is Azure's network, and by the way, AWS does not publish their network map, so otherwise I would have it. So this is the AWS current network. All the lines you see here are leased by Microsoft. They are, however, building their own links. The first one is going in partnership with Facebook across the Atlantic. I think it's going in right now. So you can see it has a world-spanning network as well. Now, Microsoft has a different approach to things. If we go back, let's say, to the GCP, and this was the case with AWS as well, note that there's a number inside of each one of those markers. That number designates the number of zones within that particular region. So you can think of a zone as an independent data center, and the region is a collection of independent data centers. So the minimum size within any of these regions is 3. So we have at least 3 areas within every region that is completely independent, has its own power, its own connections to the internet, its own management infrastructure, so that if there's a failure within one of those, the other 2 or 3 are not affected. So if you want highly available fault-tolerant compute, you would just spread your compute across multiple zones within a region. Microsoft has taken a different approach. Microsoft actually does individual data centers. So except for the US Central and France, or France and Western Europe, each one of these is its own standalone entity. So for example, if you needed highly available compute on the Western United States, you would make sure to use 2 regions, US West 2 and West US. So within the regions currently, they don't have the capability of swapping traffic back and forth or maintaining high availability. As I said before, Microsoft is learning how to do stuff in the cloud. So this is just an evolution that they realize that they're going to need multiple regions, and that is the red dot inside of the Iowa, French, and Western Europe regions. So they're starting to create these zones within the regions. Okay, so what does this mean? What this means is that these companies have been spending a lot of money. This is put together by a guy named Charles Fitzgerald, who does a review every year based on public reports, based on the filings with the SEC, to determine the amount of money actually spent on facilities. And you can see that everybody now is north of $10 billion a year, with Amazon touching $20 billion. Now, some of that is also Amazon warehouses that they're scaling up, but majority of that in recent times has been spent on the networks. That's why you see the sort of semi-hockey stick around 2010, 2011. With the result that each one of these companies has about $60 billion invested in the facilities around the world. No one else comes close. No one else is in the, I don't believe anyone's above the $10 billion level. So if you are going to compete with the top 3 vendors, you're going to have an infrastructure, your barrier to entry is about $60 billion worth of infrastructure. So that's why we talk about the top 3. There are reasons, there may be reasons that you take for approaching other cloud providers, maybe a boutique approach to things or a specialization in a particular area that you have. But in terms of just ground power and capability, no one's there. No one's in the same area code as the top 3. As an example, Gartner Group obviously tracks this. The last year's or the previous Gartner report had 14 cloud competitors. In the most recent, Gartner cut it to 6. And that includes new entrants that Gartner's monitoring. But right now, the top 3 are the only ones really performing. Okay, so what I've been doing is kind of setting up the scenario here. Any questions that people might have? Okay, so IBM and Oracle, actually a tale of 2 different companies here. IBM has been, depending on how you count it, IBM may be either number 4 or number 3 in terms of public cloud. They've done that both based on their own internal development and by buying cloud providers. So they have an integration problem, and they don't really have a presence in the same sort of presence that Microsoft, Amazon, and Google have in terms of a worldwide footprint, in terms of the inventory of capability, which is one of the reasons you want to go to the cloud. Hey, they've spent all the CapEx so that I can have a computer immediately. And their product mix doesn't match the product mix of the top 3 either. So they have servers, they have databases and such, but the products that actually pull things together and allow you to do the cloud more conveniently aren't quite there. Oracle is trying to spend its way into the cloud, but they're chasing the leaders. They spend, their reported spending is between $1 and $2 billion a year, and as we saw, Amazon, Google, and Microsoft are all north of $10 billion. Mark Hurd, who's the CEO of Oracle, was asked about this at a presentation, and he said, well, we don't have to spend as much on infrastructure because our software is more efficient. It may or may not be the case that the software is more efficient, but physically locating yourself in multiple areas around the world is going to make you much more available and give you much less latency. So I just think that IBM and Oracle are being outspent, on infrastructure and out-innovated in terms of the wider cloud offerings. Does that answer your question, Diana? Okay. What are the risks of going to the cloud? There are risks of everything. So, you know, you can spend all day identifying risks, but the major risks that tend to goof people up the most are encapsulated by these 4 areas. Unfamiliar technology, unfamiliar architectures, a mismatch of skills, a mismatch of expectations. So when we talk about unfamiliar technologies, most of the cloud is based on open source technology. Now, remember when I talked about Bill Gates being a little bit bitter about the fact that people thought other companies were friendlier, whereas essentially Microsoft was giving away, or not not taking back all the value it was providing. Open source is actually the ultimate example of that. Whether or not you're familiar with open source, you use it every day. I remember when I was first talking about Linux and open source with senior executives, they would tell me I would never ever use Linux because it's not safe, it's not supported, and then they would go to Google and then find the report that proved that, unaware that Google runs on Linux. So open source has kind of insinuated from the server side. And as a result, most of the public cloud is based on open source technologies and approaches to things. Linux being the main one. Things like Postgres, MySQL, RabbitMQ for queues. You could go on all day based on things that have become standard that are essentially open source. But your team coming from a data center, your team coming from, let's say, a homogeneous environment, may not be aware of or may not feel familiar with open source approaches to things. Another change in unfamiliar technology is the different approaches to data storage. The cloud, remember, is designed so you will only pay for what you use. So you may be familiar with signing contracts with large vendors so that you get essentially an all-you-can-eat for something like a database. One of the drawbacks for that is that it is an all-you-can-eat, so you're going to try and eat as much as you can. And you may try and shoehorn things into that are not appropriate for that particular architecture. You may try and do things like try and save video files to your relational database, or use a relational database to track web sessions. Things that are profoundly different data model than relational. With the cloud, because you only pay for what you use, you can use the products that are appropriate for those particular models. So you have a data model like, hey, Jane Smith logged in to my website. I have a timer on my website. After 10 minutes of quiescence, if someone hasn't used my site in 10 minutes, I'm going to log them off. So therefore, I'm going to keep track of every keystroke. So if Jane moves her mouse on my website, I'm going to keep track of that. I'm going to refresh the timer. If I was trying to track every mouse movement in a relational database, that first of all would overwhelm the database. The database is not meant for that level of interaction. And second, it's the wrong data model. All I really need to do is increment a counter or start a timer again based on the fact that the mouse moved. So that is what we call session tracking. And rather than a relational model, that tends to be a document model. And you don't have to really memorize these terms, but just the fact that the way we portray things, the way we model things, means that we should have different technology in order to capture that data. So different approaches to data storage. And then finally, things like, hey, I'm storing a video, or I'm storing a document, or I'm storing something that's huge. I want to throw it into a reliable data storage and not have a lot of overhead on that, what we call object storage. So the different approaches to data storage are very tend to be unfamiliar. Serverless. The idea that I can run, that something happens, a program runs, but I don't have a server running. That I have code that's sitting waiting to react to an event. But since I don't have any server running, I'm not being charged for my wait time. So some more questions coming in. So let me circle back, and if you hold on to those questions, I will circle back and address them after I finish this one, because some of the slides coming up may address these questions. Okay, so serverless is essentially I have code waiting in suspense that's going to be invoked and run somewhere. A little bit more familiar might be containers, that we want to package up our applications, package up our code, into containers, most popular being Docker, and we want these to run across a fleet of machines. And finally, big data and machine learning. You know, big data as a concept has only been around a little over a decade. The first paper about big data was actually published by Google, where Google described its internal file system. A group at Yahoo read that paper and decided that they would create a open source program that would support that, and that program was called Hadoop. So Hadoop has only been around 12, 13, 14 years. And it's been focused on sort of reporting, dashboarding, that sort of thing. In the context of the cloud, big data is just a step along the way of feeding into machine learning. And this approach tends to be unfamiliar. Unfamiliar architecture. So there may be different approaches to things that leverage the cloud more that may not be familiar to your technical staff or your architects. Things like a microservice architecture or a domain-driven design or event-driven architecture. All three of these things are ways that we're going to encompass how our compute environment gets invoked. So in a microservice architecture, we're going to have standalone services that interact with each other to create an application. Somewhat along the same lines, we have domain-driven design where different components of our application, like our security component, our search component, our e-commerce component, interact with each other by being called as services. Or we can have an event-driven architecture where instead of having a web server that responding to a click on a link does something, we can push our code to run on the system, on the user's browser, so that the browser itself is reacting to, hey, what's the user doing right now? What's it doing on this page? I'm going to go out and invoke a function. So these are all different architectures that leverage the cloud. And then finally, identity federation. The idea that rather than having a guarded walled garden for our application, we would open our application up, but we would require that someone using our application present a token. And this token says that they logged in, let's say, at their own Active Directory, or logged into Google, or logged into Facebook. They present a token, we take that token and we go back to the originator and say, hey, Facebook, is Sue Smith really a user based on all of this stuff in the token? And Facebook comes back with, yes, she is. Go ahead and let her in. And then finally, machine learning systems. The idea that we can have our infrastructure absorbing data, reacting to the data, and providing us answers based on extrapolations of the data. This leads to the fact that we may have a mismatch of skills. We may have developers that are used to homogeneous environments. A classic case is if you've been writing code in a data center all your life, and you have code that attempts to connect to a database server, and it gets an error on that attempt, your code may say this is an emergency because this data center is built to make sure that this stays up 100% of the time. I can't talk to the database server, emergency, emergency. Whereas in the cloud, an error might be coming back saying, try again in a second, or you are throttled, or you don't have enough capacity, issue an API call to increase your capacity. So in other words, developers are not used to reading the returns on errors and taking a action that modifies the infrastructure based on that. DBAs might be more accustomed to traditional relational database systems versus NoSQL systems, document-oriented systems, etc. Security teams may be more accustomed to data-centered strategies such as impenetrable firewalls, VPNs, etc. And then finally, operations teams may be accustomed to physical deployment. And then ultimately, a mismatch of expectations. The expectation of when do savings occur. How much effort do I have, how much effort and investment do I have to make in order to see the savings? Failure to account for the transitions that may be necessary. If we have to get up to speed on unfamiliar technology, or we need to increase the skill set of our people, or we need to change our management approach, these transitions are critical, and then which all lead to things like unrealistic timelines. Okay. So how do we mitigate this risk? You start small. Remember that chart that showed successful projects tend to be small projects? You take small bites of the problem. Your initial development should probably be greenfield, brand new systems, or brand new approaches to things, or brand new versions. You should use successful projects to create centers of cloud competency. I call it the infection model. That you have a successful team, you break up the team, and they serve as the core of later teams to spread best practices and how the cloud works. The most successful projects also use blended teams. A blended team, a true DevOps team, must include operations, QA, security, and DBAs. Ideally, at your sprint planning meeting, or at the very least at your sprint planning meeting, but ideally at every stand-up. You also need to create metrics to guide the projects. You need to understand what could you consider success. My rule of thumb, or the one thing that people get sick of me saying in my classes, you can't manage it if you don't measure it. And if you're not measuring it, you're not managing it. So the job of the management team is to create the metrics that guide the team. And then, as I said before, we're going to use members of the projects to spread best practices. So rewards of moving to the cloud: cost control, more dynamic and auditable security, on-demand resources, business continuity and disaster resilience, and then finally, the opportunity for continuous improvement. If you look back over the history of American industry, particularly the car industry, where we got complacent was the idea of saying, hey, it worked yesterday, it'll work tomorrow. Anyone who remembers the 1970s for the car industry remembers that there were some very, very poorly built, poorly designed, very just poor products coming out of Detroit. And that gave Japan, with things like Toyota and Honda, the opportunity to come into the marketplace. And because they were engaged in continuous improvement, they were able to crack open the marketplace and start to dominate it. Your business is probably not IT-centered, but IT is a critical cost component of your business, no matter what you're doing. So you need to understand how you can continuously improve your IT infrastructure. Okay, so back to the questions here. So Guy Perrin asks, what would be the next ones in the list? In Gartner, I believe it was Alibaba, Oracle, IBM. I forget the other folks. It tails off really quickly. You'll get things like DigitalOcean, Heroku, which are layers on top of other people's clouds. And again, each one of these may have uses. I don't want to say that there's a dominant tool. I don't want to say that there's only one tool. I want you to look at the cloud as a tool chest. There may be that you have a favorite set of tools, favorite hammer, favorite saw, favorite screwdriver. But your job is to understand the role any particular tool would play so that you can choose it correctly. Boris, great question. I'm working with a company right now that's using multiple cloud services. They are using Google and AWS together. Actually, I'm sorry, I'm working with two customers. One is AWS and Google, the other is Google and Azure. And in both cases, what they've done is pick the best of breed products from each one of those and and integrated them. So best of breed for Google is their data handling and machine learning products. Data handling, machine learning, and data warehouse. So best of breed, a product called Dataflow, TensorFlow, or cloud machine learning, and BigQuery. So best of breed big data products. Amazon, best of breed products, Lambda, serverless, which integrates with things like Glue and step functions. For Azure, the best of breed is its integration with the enterprise and with the ability to tie into the enterprise data centers. So I think everyone's going to be using multiple cloud services. It's not possible for one company to be best of breed at everything. My opinion about private cloud. Very good question. I have a poor opinion of private cloud. Unless you are looking to use private cloud as a protected area to develop the skill set for leveraging the cloud, I think that you are putting your staff and your resources up against the thousands of people who are maintaining the public cloud. I don't totally dismiss it though, because I've actually worked with a customer, a large bank, who was doing just that. They created a private cloud for the data and functionality that they were uncomfortable with exposing to the public cloud. They used the private cloud so that they would have a consistent API and consistent skill set for their technical team, so that they wouldn't have to change data center orientation to cloud orientation. So private cloud in that unique sense worked better for them. But that's a very constrained use case. Lalit, I'm sorry I don't have the profitability charts. I think AWS is the only one that's releasing them now. It's part of their quarterly reporting, and the profitability. So this is completely my opinion here. Please don't take it to church as gospel. But I think Jeff Bezos is embarrassed by how profitable AWS is. Google has always been insanely profitable. It's been up to 40% net revenue, 40% net profitability. And Amazon is seeing that level of profitability in AWS, and it doesn't know what to do with, because the rest of AWS is like 1 or 2% net profitability. They really grind things down, grind costs down to minimize price, but they're literally minting money in AWS. So I don't have the profitability charts for all of them, but AWS does report it quarterly. And there's a lot of people who are doing interesting reports trying to break out what the profitability of all of them are. John Lee, for China and Japan regions, what is the scenario? Also Alibaba Cloud. Okay, so as you probably remember from the maps, and by the way, those maps I showed you are freely available online at the cloud providers. For Japan, you have all the cloud providers are trying to create as many regions as possible within the country. Obviously, you have the constraints of real estate prices, etc. But Japan itself is adopting the cloud like crazy. I would say that the cloud adoption rate is maybe even higher than the US. So the density of coverage for their, particularly in the Tokyo, Osaka area, so on the main island, it's always going to be excellent coverage for the cloud providers. If you are working with the cloud providers, though, in Japan, and you're in one of the outer islands, I would ask them about their network coverage. I know Google has very dense network coverage around Japan. Alibaba Cloud. I really think Alibaba is going to be coming on. I think that Alibaba is using this particular time to their time and their resources to learn about doing the cloud. There is a, let me put this up in the chat window. There's a guy named James Hamilton. Why isn't this working? Sorry, my chat window isn't working here. Oops. Hey everyone. Sorry about that. My web page crashed on me. Can you still see my screen? And can you hear me? Can folks still hear me? Okay. Let me, sorry about that. Okay, everybody, hang on a second. I'm still trying to get the screen back. Okay, can you see my screen now? Ah, there we go. You'll be happy to know none of this is running in the cloud. It's running on my Mac. Okay, so back to the questions here. So yeah, the Alibaba Cloud, Alibaba is coming on strong. They're spending a lot of money to do it. They're very smart people. I think that they will be a presence. If there's going to be if there's going to be 4 competitors, Alibaba would definitely be one of them. So Nikita asked the question, between Google Cloud and AWS, what would be a better platform and offer technologies that would support a data warehousing solution? Your choices with AWS and Google, Google has a very flexible petabyte scale data warehousing solution called BigQuery. It is, in my opinion, best of breed. And the competitive products from AWS would be Redshift and Athena. They're very different products. Redshift is you having to pay for compute facilities that are big enough to hold your data. And Athena, though, is your data is stored on your simple storage service and you run queries as necessary. So Redshift, you're paying by the hour for the compute facilities. Athena, you're just paying for it every time you query. BigQuery, you store the data, and you are charged 2.6 cents, I think, per gig per month. Once, and then when you query it, you charge $5 a terabyte. The longer the data stays in BigQuery, the cheaper it is. So for my mind, for 80 to 90% use cases, I think BigQuery is the better data warehousing solution. So Vitaly asked a great question about Foreshadow, Meltdown, and Spectre. I would actually say that, well, for example, Meltdown and Spectre were discovered by Google, by the Google, the Alphabet decision called Google Zero. They did not announce Meltdown and Spectre until their entire cloud had been patched for Meltdown and Spectre. So the question is, in terms of mitigating risk there, is how much resources or how many resources any individual enterprise or organization can have to do things like patch an entire data center for things like Spectre, Meltdown, Foreshadow, etc., versus the public cloud. And that's a question that you have to answer in terms of your own risk mitigation. But I would put it forward as maybe the public cloud has a better story in some cases for mitigating those security problems. Sergey, don't know. So Sergey and Sandesh, the slides will be available after the class. Boris, I answered this question about multiple cloud services. Yared, that's a very good question. In many ways, I think that for my particular one, I actually have a software company, and I've been in operations my entire career. What I lose in terms of using the public cloud is grunt work. Is I don't have to kneel on concrete floors anymore. I don't have to create networks. All this stuff is done via API calls for me. So the actual grunt work, or as Amazon calls it, the undifferentiated heavy lifting, is done for me when I make the API call. And I'm focused on the application or the actual value I add. So I don't think I'm losing that. For me, I don't think I'm losing that much in terms of using the public cloud. Okay, and Bob Seal, you've got a question. How do the top 3 address risks of handling clients' intellectual property on the cloud? there's a sign that I saw on BART in the San Francisco Bay Area. It said, "Dance like nobody's looking, encrypt like everybody's looking." All the major cloud providers either provide or automatically encrypt your data in flight and at rest. So that happens automatically with Google. It is an option with AWS and Microsoft. You should, on top of that, encrypt your own data. And all of the major cloud providers have a way to do it in a very secure manner. So if you have anything that needs protection, protect it and leverage that. Yeah, Jeff, good point about the existing infrastructure that IBM has. A lot of again, my opinion, not word of God. I see a lot of their challenge being many of the things they provide as the cloud are purchases, and there's an integration process that they still have to go through. They currently are 6 regions, 18 availability zones. All of the big 3 are north of 15 regions. Okay. Bob, so following on to that, the intellectual property, et cetera. The only guarantees that I can make you in terms of intellectual property, in terms of warranties, et cetera, is leverage the controls, to leverage the technology to take control of it yourself. You know, you can talk to the representatives from the cloud provider. You can talk to the lawyers. Lawyers talk to lawyers, and they make words that I don't understand. I'm just an engineer. I deal in reality. They deal in the law. So I'm not sure how much protection they can provide. I know the level of protection I can provide from leveraging tools like the key management system, encryption, TLS, SSL, et cetera. Okay. So question from Anoop about how is event-driven architecture different from microservices architecture? Event-driven architecture tends to be programs, things like cloud functions, serverless, et cetera, that are invoked as a result of changes or updates to something. So a classic event-driven architecture would be if you had, if you look at my LinkedIn profile, linkedin.com, LI, Jon Gallagher, there's a picture of me, and you're all familiar with LinkedIn. You know, your picture pops up everywhere, and my wife spent hundreds of dollars on a professional photographer to make me look that good. What LinkedIn does is I sent them a 5 megabyte JPEG, and they immediately generated thumbnails. With the cloud, what you can have is a facility that says, okay, I'm going to accept a picture from you, an avatar or something. When this gets uploaded into a storage bucket or an object facility in the cloud, that can trigger a program that automatically generates thumbnails. So you can have, as people change things, as people interact with the system, you can strip away the code from your website and have this tiny little function that says, oh, I have a new object uploaded to this bucket. Hey, look, it's a JPEG. Oh, and by the way, with machine learning, I can put it through a cycle to determine that the image is not objectionable, it's not sexual, it's not violent, etc. So I can do that first one and make sure the avatar isn't gross, and then automatically generate the thumbnails, and I have not paid for any server, I've just paid for the execution. So that's kind of the difference there, is the infrastructure drives the actual processing. Anoop, another good question. Microservices architecture is an approach that all of the clouds support. with different tools. So with Google Cloud, it'd be something like Google Cloud Functions, App Engine. With AWS, it'd be Lambda or Elastic. Oh, it just popped out of my head. I'm sorry, Elastic Beanstalk. Be functions in Microsoft. So all of them have those capabilities. And also privacy concerns. Again, the infrastructure exists such that you can control your own access to your systems. Now, all the major cloud providers guarantee that they will not do things like examine your databases. They will not use super user access to anything in your system. They are more than willing to sign contracts that specify that. And beyond that, because we don't trust people, we can do our own encryption and such. So Diana has a question about SaaS versus PaaS. SaaS being software as a service. The ultimate expression of that would be something like Salesforce, but it also might be something like running your relational database service for you. So in Microsoft, it would be Cloud SQL Server. In GCP, it's called Cloud SQL. In AWS, it's Relational Database Service. Again, I'm going to punt and say that you should understand what your needs are, understand what your constraints are, and explore the offerings that the cloud providers have. Okay, sorry, I'm going through the list of folks when I crashed. Okay, Deanne, I'm sorry I don't have any architectural documents for that. I really should have put it together for this presentation. I apologize I didn't. You should have my email address. Those of you who if you want a multi-cloud architectural diagram, please email me and I will send it out to you. I have one, but it has names on it, and I need to strip all the names off and make sure that it's okay. Okay. So Guy Perrin asks, what about banking industry cloud adoption? You have banks who are charging at the cloud. Banks and bank-like systems, Capital One, Simple, and even traditional banks that I've worked with, I'm sorry I'm not going to name names, but they are traditional New York money center banks who are all moving to the cloud incredibly fast. The money center bank I worked with has identified probably 75% of transactions, just off the top, 75% of their transactions that occur currently in data centers can be moved to the cloud without any problem. So that's just enormous. Okay. So Victor has a question about government institutions, data protection, record keeping compliance. Yes, those are concerns for public cloud adoption. It's one of the reasons why Microsoft and AWS provide what they call GovCloud. So the GovCloud in the United States is built for data governance, encryption, et cetera, all the standards that governmental entities need to comply with. To a large extent, the public versions of those are fully capable of maintaining it, but GovCloud itself just gives you a safe harbor for operating. So if you are working with an entity, federal, state, municipal, county, et cetera, or non-governmental entities, water districts, et cetera, you can work within GovCloud and be assured that you are FISMA, ITAR, FedRAMP compliant. Okay. Oh, my email address. Let me put my email address. I put it up and it's going into the chat window right now. Oops. Okay. Sergey, that is a very good question. And that is something, so I'm sorry, Sergey's question was for the security of data in each individual country, what about the Patriot Act? It seems it will not protect the total country's data from outside companies. I have an answer for that, but that is one I do not want to be wrong about. That is something I would ask the representatives from AWS, from Google, from Microsoft, from any cloud, is to make sure that they cover that with you. There is a process of the technical account management will be able to work with you on that and guide you through this process. Sina has a question. What using cloud only benefits people if they use it wisely? Does going to the cloud actually cost less on average? There is I worked with a company that just went to the cloud and did not put any management around it. They basically gave everybody access to do anything they wanted, and as a result, they ended up with historic bills. Think of the data center. Think of, and it doesn't have to be as constrained as this, but think if you were going to add more compute to the data center, what's the process of spending that money look like? The process is you need to create a case, you need to forecast and understand, hey, I'm going to need some compute. Then you need to go to your boss for budget, and then you need to go to purchasing to spend that budget. So there's a whole process of things going on that you need to that you needed to go through in the data center. If you didn't put the right kind of constraints in the cloud, then people will just say, oh, I just need more compute and I want the biggest one. There are compute instances that cost you a penny an hour. There are compute instances that cost you $9 an hour. So it is, as Sina asked in her question, it benefits people only if they use it wisely. But that would be the case with a corporate travel card, with any sort of ability to spend corporate money. If you have put constraints on it, if you've put controls on it, then yes, the cloud does cost less on average. Oh, Inderjeet. That is Inderjeet asked, do you have a checklist of security questions to ask to cloud providers specifically for big enterprises? I do, and again, if you send me email, I will send you that checklist. And my email's in the chat window. And last question I have so far is this being recorded? Yes, it is. It's being recorded, and we will generate that and have it available to you. Okay, so any more questions? Oh, my LinkedIn profile? Okay, hang on one sec here. You just want to see the picture, don't you? You just want to see what my wife spent so much money on. And there's my profile. Okay, Madi asks, Madi, very good question. Madi asks, sorry I joined late to the webinar, which one is better for online shopping business for a retail company in Canada in terms of performance and maybe price? Again, I'm sorry, I'm an engineer, it depends. And one of the things that we'll have, Suda has a question, is there a comparison of cloud offering for ready reference? In the slides, I have two different sites that will do a point-to-point table reference. I didn't put a table in these slides because it changes so often. So I dump it on other people to make sure that they maintain that. Yared asked the question, what are risks public and private versus in terms of disaster mitigation? The public cloud for me is where I do all my disaster mitigation, my disaster recovery. I have clients that are still data center oriented, but I've convinced them to use the cloud as a disaster recovery and disaster mitigation. One client, I've moved from San Diego. I live in Portland, Oregon. This client is still in San Diego. And for those of you unfamiliar with California, and people think California doesn't have any seasons, we do. We just have different names for them. The seasons are called fire, flood, earthquake, and drought. So disaster happens all the time in California. Currently, we have wildfires. And my client had one wildfire come within a quarter mile of their office, and that convinced them to go to the cloud. Because the data that's sitting in the cloud can be moved here to Oregon, over to Virginia, into Iowa. You know, unless an asteroid hits planet Earth, the public cloud is going to have some capacity that remains untainted. So Google just opened a region in Los Angeles. You know, Los Angeles has lots of disasters all the time, but it's very easy for you to back everything in Los Angeles up to Oregon or Iowa. So the public cloud for me is what I use to mitigate disaster. Okay. Anoop, so a question about which cloud offering is suitable for container-based applications. All the major cloud providers have a container offering. You also asked about Kubernetes. Kubernetes is Google's tool. Google has been using containers for over a decade. And the system they used to coordinate all the containers was called Borg. And they released it as an open source software system that is now called Kubernetes. Little joke, if you look at Kubernetes, Kubernetes is Greek for helmsman, or the person who steers the ship. The symbol for Kubernetes is a ship's wheel, but the ship's wheel is wrong. A ship's wheel has 8 spokes. Kubernetes only has 7. That's because the original name for Kubernetes, because it was spun off from the Borg, the original name for Kubernetes was 7 of 9. Is it possible to be any nerdier than that? So that is why there are 7 spokes in the Kubernetes logo. And Anoop is asking GCP, EKS, Amazon-based Kubernetes. You should look at the features for each one of them and determine what matches your best use case. In general, I think that the Google Kubernetes engine is the best for a couple of reasons. One is that Google doesn't charge you for the master node. If you're familiar with Kubernetes, you have a cluster, a master node, and worker nodes. In GKE, you are not charged for the master node, and that's a pretty significant savings. That and the fact that the Google engineers are over half of all the pull requests for Kubernetes. It's an open source project, it's maintained by Apache, but Google is still maintaining Kubernetes. So over half the PRs are from Google engineers. So they are intimately involved with making sure Kubernetes stays up. Hyjin is asking about, do you pay for static database or documents when they're not used? You pay for the storage of them, yes. But if people are not accessing them, you do not pay for access. So you do not pay for any servers. But because it's actually stored by them, you do pay for that. So Santosh asks, do big cloud providers disclose ransomware attacks? Do they deal with it and prevent it? Yes, they prevent it. Remember that the minimum size I'm aware of the security staffs for any one of these cloud providers is a couple thousand people. I don't know that any of them have suffered a ransomware attack. I have no doubt that they're under constant attack for DDoS and those sorts of things. So I assume I have not heard that they've been taken down by one of those. Oh, Yeager, my advice for people who are new to cloud. Okay, pick one and get certified. Pick one and go through all the certifications for that particular cloud. I started off with AWS because I started off in 2006 and it was the only cloud. I got all the certifications for AWS, and now I have all the certifications for Google, and I will at some point get all the certifications for Azure as well. It's a different using the cloud is a different mindset. So I would say pick one of the three, whichever one you're most comfortable with, and dive into the certification process so that you can prove that you've mastered cloud technology. Out of the three, I would say because Amazon is the oldest and has the largest market presence, if you don't have a preference, I would say Amazon, because that's the one that more people will be hiring for. So, but if you come from a Microsoft background, maybe you're more comfortable with Azure. If your intention is to eventually be working with big data and machine learning, then I would pick Google. Karen asks, advice for a traditional DBA moving to learn and work on cloud technologies. Actually, pretty much the same as for Yared. Pick one of the providers, the one that most closely matches your skill set, or the one that that looks to be going down a path that you think would be valid. I think the dominant player in big data and machine learning will be Google, but you might choose something like Microsoft because you're more familiar with SQL Server. But I would pick one to learn how to be cloudy, to be able to learn how to maintain multiple databases, multiple different data models, and work from there. Yared asks, what about cloud security? What do you mean? Do you mean in terms of learning about cloud security, or do you mean how secure is the cloud? Well, let me paint this picture for you. The cloud security is a shared responsibility. The cloud providers can and do guarantee that the facilities they provide are secure when you go to start them. When you go to access a system, the cloud provider can guarantee it's secure. However, the cloud provider cannot prevent you from starting up a Linux box and removing the root password. So that's what they talk about, a shared responsibility to say that, hey, we will start off secure, we'll give you the tools to be secure, but you have to use the tools. And every cloud provider talks about that. So cloud security is a iterative process between you and the cloud provider. Lalit, I don't really feel comfortable talking about discrepancies between AWS and Azure. Everybody has their own strengths, everybody has their own weaknesses. You know, the strengths of Azure integration with the enterprise identity store. You know, it's very easy for you to extend your corporate Active Directory into Microsoft Azure. A drawback of AWS and Google is that you're going to have to create some sort of federation process between Active Directory and Azure, AWS, and Google. So those are the kinds of things that occur to me. But in terms of slagging one versus another, I'm not comfortable with that. Santesh asks a great question. Is there a good course or blog or link for general networking configuration best practices in AWS and GCP? Obviously, WebAge. We have a course catalog that will help you with that. So please look at that first. Take a look also at A Cloud Guru, Linux Academy. Trying to remember the rest. Cloud Academy, O'Reilly, and the providers themselves, and see what matches up with your own level of expertise, and see what can leverage your expertise and add to it. So the good thing is there's a broad spectrum of people who can help you with the process, and obviously WebAge is part of that. But me personally, I try and say, I know X, I need to understand Y and Z. Who's going to not teach? Who's going to at best review X, but make sure that I know Y and Z? John Lee's asking a question. In Internet of Things, which cloud has a better edge? That is a really good question, and every cloud has taken a different approach to that. It depends on how smart your devices are. AWS has a fascinating product offering in IoT where you can extend Lambda all the way out to your IoT devices. And I'm trying to remember what it's called, Greenfield, something like that, Greenleaf. Anyway, so if you're designing IoT, you could integrate it with AWS, and they'll go all the way up to data networking. They'll go into radio protocols. So they have an approach that could be soup to nuts for you. With existing systems, everybody has ways of capturing data and getting it into the system. Everybody has dedicated IoT products. So it kind of depends on how smart, and I put air quotes around smart, your IoT devices are. If they're smart enough that they can communicate over the internet with HTTP, then there's some very, very low cost approaches for Google using PubSub. If you're building the device itself, you might want to look at AWS for their chip packages. And if you're integrating into the Microsoft stack, then Azure might be your best bet. So Anoop is asking about OpenShift. I I'm not sure that private cloud is a good investment of time. And again, that's my prejudice. That's completely my perspective. If I have resources and I want my resources to be effective as quickly as possible, I'm probably going to point them towards the public cloud unless there's some sort of overwhelming reason to stay private. So with that, let's go back to the presentation and finish off the last section, which is actually making the decision. So this class has been a high-level business process. In the slides itself, I've been talking about business issues and management issues because those, I think those get ignored all too often in the cloud discussion. What does management have to get involved in? What are the things that management has to manage in terms of risk? Coming down to the decision itself, one of the easier aspects is how much does it cost? The least expensive from just a simple stand up a thing is typically Google Cloud. So what I did here is I went to Amazon's calculator, total cost calculator, and I picked a scenario. And it came up with this price, $626. Then I went to Azure and duplicated the scenario in Azure, and then I did the same with Google. And you can see that Google is significantly less expensive. Almost a third less. The reason for that, now these prices here are what we call on-demand prices. This is literally out of the book, and the price is generated by the calculators themselves. There is no discount applied for things like reserved instances or for contracts with the supplier itself. So if you're just doing on-demand, Google is typically the least expensive. The reason for that is the longer you run any instance in Google, the cheaper it is. If you run a server for more than 25% of a month, so you run it more than 8 days, Google automatically gives you a discount. If you run it for a full 30 days, the result is something like 30% off, which happens automatically. You don't have to sign anything. You don't have, there's no contracts. There's nothing. So you just automatically get a discount. So in terms of who's least expensive on an apples-to-apples basis, it's probably Google. Now, both Amazon and Microsoft offer special deals. Amazon offers what's called reserved instances. Azure offers you the ability to talk to a Microsoft salesperson and negotiate a contract. So there are ways to get discounts off of what we see off the screen. It's just that Google will automatically give you discounts. Right now, in terms of security, all three providers are equally capable. However, Google is introducing a new approach to security called Titan. And what Titan is a chip that goes on the motherboard of all Google servers, which will guarantee that only signed code in a particular configuration can run on that server. So as an example, you would have a server, you would install your software on it, and you would sign this saying, this is how the server should look. The executables on the server should look. Then when this starts running on the box, the Titan chip examines all the processes that are running, creates a hash of them. If the processes do not match the hash that you signed, then the Titan chip can shut off the system. So if someone injects malware or someone makes a change to the software that didn't follow your CI/CD pipeline, that server will automatically shut off, or can be automatically shut off. You can be alerted. There's different ways. So what Google will guarantee is that only the software that you've put through a CI/CD pipeline and you've signed will be executed. So at that point, they're way ahead on security. Now, this is an outgrowth of what's called trusted compute modules. that Microsoft developed. So when Titan is in place, Google will be ahead. I would anticipate the other cloud providers will catch up very, very quickly. So this is a race where everybody wins. This is a race where the cloud is as secure as possible, as secure as they can make it. Now, remember, nothing prevents the users from doing something dumb. And many of the cloud security breaches that you've heard about have been users doing something dumb, such as creating an S3 bucket that's open to the world and then sticking classified imagery in it, or sticking all the voter rolls for the city of Chicago. There's an enormous number of times when people have just removed the security and bad things have happened. But as things stand, every cloud provider is equally capable right now. When the Titan chip gets rolled out across the GCP fleet, Google will be ahead and will be that much more secure. Okay, so in making the decision, we have to look at our risks. And remember, one of our risks was unfamiliar technology. So if your company is currently a Microsoft ecosystem, Azure will probably be less risky due to familiarity and the ability to extend things like Active Directory. If your company already has experience in the cloud, that experience was probably already AWS. If you've hired people who have experience in the cloud, more than likely they know AWS. But if the company is comfortable with open source and the open source approach to things, Google will be more familiar because Google is an open source company. So it's Kubernetes is open source, TensorFlow is open source. Basically, the innovations that Google has done, they've released to the world, and they're being maintained by the open source community and Google. So the result is that you have a wide base of people who understand better how to run things like TensorFlow or how to run things like Kubernetes. And then Google, if those people come in with that skill set, something like the Google Cloud Platform would be more familiar. Unfamiliar architectures. So if the company is obviously currently a Microsoft ecosystem, Azure will probably have architectures that are more familiar. If the company is already familiar with client-server architectures, with the ability for things like message passing and queues, then it would be AWS or GCP. If the company is using or wants to extend the use of containers, GCP or Google Cloud Platform probably has the most complete offerings. Mismatch of skills. Again, if your company is already a Microsoft ecosystem, if the people in your company have gone through Microsoft their whole careers, Azure is probably less risky. If the company is already experienced with the cloud, it's probably been on AWS, and that also, AWS having been in existence longer, there are more people, the resource pool that knows AWS is probably deeper. But GCP is investing heavily to catch up here. I work with Google on their training, and they are pushing training like crazy. So I would anticipate that the resource pool will know more about Google very, very quickly. Okay, and then back to the business issues of mismatch of expectations. Start small and realize that a successful cloud project is one where your resources have gained new skills and spread those skills throughout your organization. Which means that you need to pick the cloud that matches the goals. What 2 to 5 years from now, where do you want to be? Do you want to be a cloud that do you want to be in a cloud that matches your cost control goals? Do you want to be in a cloud that matches your goals to leverage big data? You know, if you're an insurance company, one of the problems with an insurance company is ensuring things like, hey, I just wrote this policy. Did I encompass all the possible risks? That is an ideal case for machine learning. You know, if you're an insurance agent who's writing a policy, you want to get the commission. You obviously want to do a good job. You don't want to defraud anybody, but you want to get that commission. Machine learning can look through the whole thing and say, well, one thing you forgot is this area has been reclassified as a floodplain or a fire hazard, or we discovered a new earthquake fault. So machine learning is there to increase the skill set of your people. And it may be something that you want to do down the line. So as I said before, I've got 3 areas where these technology comparison charts, and they'll be part of the slides that you get out. RightScale is a company that's been in the business of coordinating multiple clouds. They've been doing it since the beginning of the cloud. I went to my first RightScale user conference in 2010. So they have a historical perspective on the cloud, and that cloud comparison tool can show you sort of a apples to pear to grapefruit type comparison. Red Pixie focuses immediately on AWS, Azure, and Google, as does Calent. So folks were asking about those before, and I would say those 3 areas, and again, they'll be part of the slides when you get them. And that is actually where we're finishing up here. So looking back at the questions, Geary asks, doesn't private cloud make more sense for government organizations? It might, but government organizations have been in the cloud for quite some time. The first one that we know about, that we heard about publicly, was AWS creating a private cloud for the CIA. So government organizations don't necessarily need to be part of the public cloud. They could contract, like the CIA did with AWS, to create their own private cloud. There's also a DoD contract going out for a $10 billion cloud contract, which will kind of be a private-public blend. But smaller government organizations can leverage Microsoft or Amazon, where they've created specific clouds for governmental entities. Again, these are for US entities, but if a government outside of the US committed itself to leveraging the cloud, I'm sure the cloud providers would be willing to listen to create a gov cloud in that area. So Louis asked the question, which Google certificate is good for beginners? They just announced a beginner. Let me look that up. So if you go to Google Training, self-paced training certification, there's something called an Associate Cloud Engineer. And it is the kind of the entry-level certification for Google Cloud. It's a really solid test and certification. And then Louis, you said that you're interested in big data and such. From there, you would move into possibly taking the professional data engineer certification. So Sina asked the question, are Google and Azure using open source software to tune their data centers like Amazon and Zen Server? Yes, absolutely. Remember that Google invented a lot of the open source software that other people are using. So I forget what Google is using. So Amazon uses Zen, and Google uses the other Linux hypervisor, but it does containers on containers above that. Azure is also definitely using that. They're definitely becoming more of a Linux shop. Louis, so again, to remind folks, I'm an engineer, so Louis' question was, amongst the top three, which one has a better presence in IoT? As an engineer, my answer is always, it depends. The product offerings, the base level product offerings of I have data in an IoT device over the internet, otherwise HTTP, then the three providers provide roughly equal service. It gets into but depending on what you want to do, whether you want to build the IoT device yourself, whether the IoT device wants to do things like power saving networking protocols, I would establish those use cases and then see which of the cloud providers match that. Okay, other questions? And by the way, you all have had outstanding questions. This has been really great. I very much appreciate you all asking the questions. And remember, if you have a question, there's probably 5 other people who also have a question. So be the brave one and ask your question, and at least 5 other people will be grateful you did. My thoughts about IBM Cloud is they've got a lot of things to catch up. They have to make a lot of investment to catch up to the infrastructure of the top 3. They have a integration challenge in pulling all their purchase systems together. So if they can make it, great. But if they can make it, meanwhile, the top 3 are innovating like crazy. The only way the top 3 can differentiate themselves, there's 2 ways they can do it. Better technology and better pricing. And Amazon, Google, and Microsoft are doing this constantly. They're constantly changing and decreasing the cost and constantly innovating. So it would be incredible, and I don't know how people will catch up with that. I'm not going to say they can't, but that is the challenge. So Oliver asked the question, is there an AWS equivalent to the associate search? Yes, there is. So Amazon has 1, 2, 4 associate levels. There's associate architect, associate sysops manager, associate developer. Yeah, those 3. They also have a level below that, and I don't mean below in terms of to denigrate it. I mean as to create a better pathway for people starting off, kind of an entry-level certification. And let me pull that up. It's called Certified Cloud Practitioner. So the Certified Cloud Practitioner in AWS is roughly equivalent to the Cloud Engineer for Google. It's foundational. It's meant to be the impetus for it. Sergey, I believe you will. I'm not sure about the mechanics of that. You'll probably get a link to download the presentation. Louis, thank you very much. Your participation is greatly appreciated. Madi, I'm sorry, I have not had much experience with the JD private cloud, so I don't really have anything to add to that. Roy, Watson on the IBM cloud. So Watson, as we all know now, we're technical folks, Watson is a machine learning system, very, very flexible. It's a question, though, of whether its use cases match your use cases. So all the cloud providers have what we call pre-canned or pre-made machine learning models available now. So natural language, vision, those sorts of things. Watson sort of takes it a step above that into conversational. So it's a case of, it's a very powerful system if it matches your use case. Martin, are the associate level certifications useful in real world scenarios? Yes, they are. If I had a DevOps group and I was moving to the cloud, I would want everyone to be at the associate level, including people like the project manager, product manager, engineering management. I would want everyone at least at an associate level because it gives you a common language and a common set of meaning. You know, you've tested to make sure that if I say block storage, everyone knows what I mean, versus object storage. And I would say the associate levels, in terms of job prospects, they would definitely be developer level. I would say that if I was hiring someone to be my architect, I would want a professional level. But if I was looking for someone to be part of my cloud team, I would want at least associate level. Yeah, the professional level dives deep. So all of the professional exams dive into scenarios and do things like business cases where you read the business case and then you react with some sort of architectural or data engineering approach. So they're senior level management or architect type tests. The associate level is something I would want to see for my developers. Thank you very much, Victor. Have a great one. Martin, thank you. So any more questions? If not, I will give you back the rest of the day. So I'll give you final call for questions. Yared, yes. That is something I've found true. The approaches to using the cloud are universal. So things like leveraging object storage as a data bus, creating loose coupling for message passing rather than direct RPC calls, architectural techniques, development techniques are universal. The APIs change, maybe the capabilities change, but the approaches are universal. So that's why I tell people, pick a cloud and learn how to do cloudy thinking. Okay, everybody, last call for questions. Okay, thank you all very much. I hope everyone has a great weekend. If it's hot where you are, I hope you stay cool. And I hope to see you I go to a lot of these events. So I go to Google Next, I go to reInvent, I go through some of the summits, and now you have my picture so you can track me down. So if you'd like to, please go ahead and say hi. If you want that diagram I talked about, please send me email. And you should be getting a link to the presentation in a little while after I shut things off. So thank you again, everyone. And thank you for your time. Thank you for your questions. And have a great rest of your week.